if we're asked to find the extrema for this graph, of course, our steps are the same. The first thing we want to do is find the derivative. Power rule, multiply and subtract. Multiply and subtract. Remember, the derivative of a constant, that's 6x to the 0. When we multiply and subtract, that goes to 0. Now, I'll set my derivative equal to 0. And again, I want to set up this idea of the zero product property. This times that equals 0. So I'll factor out a 12, and I'm left with x cubed minus 1 equals 0. I know some of you have trouble with this. Let's make sure. 12 times x cubed is 12x cubed. 12 times negative 1 is negative 12. So you can always distribute to make sure your factoring has gone correctly. Now, I'm going to set each of these equal to 0. 12 is equal to 0. That's not true. I don't even have to worry about it. 12 is not equal to 0. There's no variable in that. And x cubed minus 1 equals 0. So x cubed equals 1. And x equals the cube root of 1, which is 1. So I only have one critical value. Let's see. The function value at 1. Notice, if I want the y value, I go back up to my original equation. So f of 1 is 3 times 1 to the 4th minus 12 times 1 plus 6. So f of 1 is negative 3. I also want to find the function value at 0. So if I do left endpoint, critical value, right endpoint, and I make my little chart, it will help me pick out the absolute max and absolute min. The left endpoint is at 0. Now, when I do f of 0, this goes to 0, this goes to 0, and that will leave me with 6. My critical value is 1, negative 3, and my right endpoint is going to be 4. Now, to find the function value at 4, I need to find f of 4. Note, that means I need to do 4 to the 4th times 3 minus 12 times 4 plus 6. And when I do that, perhaps with the help of a calculator, I get 726. So I didn't show that work, but very straightforward, something you've been doing from algebra for years and years. Now, I'm just comparing these y values. Notice that these two are candidates for maximum values. This is our absolute max because it's the highest y value. It's found when x equals 4. Here is our absolute min because it has the lowest y value. That's all I have to do. So the question I have for you is, from this particular graph of f of x, or this function, f of x equals 3x to the 4th minus 12x plus 6, we found left endpoint 0, 6, a critical value at 1, negative 3, and then 4, 7, 26 is somewhere right like that. Could we draw a sketch of this? Heck, yes, of course we could. It's got to look something like this, right? Notice we have only one critical value where our derivative, f dash of x, is equal to 0. Whenever we have a max or min, we'll find that the derivative is equal to 0. So here we have 4, 7, 26. I know it's not to scale, but it gives you an idea of what this graph looks like. And our minimum value is at 1, negative 3. So based on our work with relative and absolute extrema, we can come up with a graph very easily of a function on a closed interval from 0 to 4.